In the previous practical, we have seen the various parts of the lathe and various measuring and comparing instruments, right? And we have seen like the work holding device, the carriage, the tailstock, the headstock of the lathe. We have seen all the details about the lathe machine. In this practical, we are going to prepare or we are going to make a job, which is practical number 2 in this machining shop. You have to make a job according to the drawing given. I will show you the drawing and also the manufactured part also. But we will see all the process, how the job is made, how it is fixed, how it is aligned, how the feed is given, how the depth of cut we give, right? What is the role of this particular chuck? What is the role of this tool post? What is the role of this tool? Everything we will see, right? So, as far as this practical is concerned, we will start with cutting the raw stock, cutting the round bar to the length from our raw stock. Okay. So now we will quickly move to power saw, where this raw stock will be cut from the long rod, right, for our job. Okay. So let us move there. Pause kara na. As we already have seen, this is our power saw, right? This is the power saw. You can see, already I have explained you, this is a moving ram, right? Reciprocating ram, that is the crank arrangement, the motor gears and everything. The gearbox is also there, that is the gearbox, where the rotary motion is getting translated into this reciprocatory motion with the help of this crank. Okay, so the setting is going on. Taireji is setting the job so that it can be cut. This is the lead screw for this vise where the job is clamped, and we will cut this clamp according to the length, right? We need 100 mm of length, total raw stock 100 mm, right? So this is the stopper which already have been marked up to 100 mm. Okay, so this will come and will stuck over here, and this will be cut at exactly 100 mm. This is the stopper which is set at 100 mm from the blade. Okay, so this is cutting blade. So now the thing will start. This is the coolant tank from where we will keep this coolant flowing all the way, right, in the machining zone. Okay, can you see? Okay, so this is the cutting, right? You know, when any metal is cut, there are several physical phenomenon, like increase in the stress, and increase in the stress give rise to the increase in your heat, right? So the heat will be generated while cutting the metal. That is why this coolant is flown from the pipeline to the machining zone here. So it will get cut in maybe in 5 minutes. At a time we are cutting 2 bars at a time, right? So the total distance what this blade is traveling, it is called stroke. This is the stroke of the blade, right? Whatever distance it is traveling from this side to this side, end to end, that is called stroke, and that stroke is adjusted from this particular crank, right? So you can adjust the stroke, right? So right now we are cutting 2, we can also cut many, right? So the time will increase. So this is how the cutting of your raw stock from this bar, long bar, right? Generally those bar comes in 6 meter of length total, but for the sake of manufacturing the job we need just 100 mm. According to the drawing, raw stock should be 100 mm so that we can cut the part, and minimum material has to be taken out of the job so that we can have that particular less amount of time and less amount of energy to manufacture the job. So raw stock kept at the minimum. Okay, so this is how the thing goes. cutting it at the end. This job will be cut. You can see here. From here I will show you. So this will be the clear region. So you can see the cutting is still on, and your round bar of 100 mm length and 25 mm diameter. The diameter of the bar is 25 mm. See, the cutting is done. It's completed, and we have got those two raw stock over here. We will use one. This one we will use, right? So we will take this raw stock to our machine, where the machining will be done on this part. Okay. So by the time Tadiji is setting this, I'll show you quickly the job drawing. Okay. So you can pause your video while you are looking at it, and can see this. This is the job drawing. This is the job drawing. According to this job drawing, we have to manufacture a product. This is the final product, right? Maybe this is a stepped shaft, right? Where for 20 mm of length, all the dimensions are in mm. You can see, you can read over here. All dimensions are in mm. And material, what we need, raw material, we need MS rod. MS बोलने का मतलब है mild steel rod, right? Mild steel rod. Mild steel rod of 25 mm of diameter. See, this is your raw stock. What we have cut from that on that power saw, right? So, ताड़ी जी है क्या वर्नियर कैलिपर, right? See what we were discussing. This is your raw stock, and what is the raw stock? We require MS rod 25 mm of diameter and 100 mm of length. So 25 mm of diameter and 100 mm of length. So we will verify this on vernier caliper. Okay. So we can see this is 24 point something, left 25 approximately, because it is a rolled bar. So it's 25 mm here. You can see this is 25 mm, 10, 20, and this is 25. Okay. So this is 25 mm of diameter, and you can see here it's 100 mm of length. Can you see? The 0 is coinciding with the 100, right? So 100 mm of length and 25 mm of diameter. Now, out of that, we have to make, for 20 mm, we have to make the bar of 16 mm with the turning operation, right? And then 35 mm of length for 19 mm of diameter, then 40 mm of length for 25 mm diameter. At the end, you can see there are blunt edges. Those blunt edges are called chamfering. So 2 mm by 2 mm का chamfering हम लोग यहाँ करेंगे, the 45 degrees, right? It is the chamfering. Chamfering is the process where we blunt the end edges, right? So this is turning, and at both the ends we will perform the facing operation, right? What I said in the last practical, that in turning you reduce the diameter, in facing you reduce the length. That means out of this 100 mm, what we will do, we will make it total length of 95 mm. You can see 20 plus 35, 55, 55 plus 40 is equal to 95. Okay, and from 25 mm of diameter we will reduce it to 22 mm, 19 mm and 16 mm. So this is called step turning. Individually, if you see this is a turning operation, but if you go stepwise, the whole thing will be called as step turning. So at both the ends we will see chamfering of 2 by 2, 2 mm by 2 mm, okay, and all the dimensions whatever in this particular job drawing are in mm. Okay, So this will be your final product. This will be your final. We will verify this. We will verify this with the help of vernier caliper. Okay. So let us go on the machine and start our job. Okay. So here is the setup of lathe. The job will be held in this 3-jaw chuck, self-centering 3-jaw universal chuck, or universal 3-jaw chuck, or self-centering 3-jaw chuck, right? I already shown you the introduction of this. So this is the chuck key. With the help of this chuck key, we are aligning this job at the center. Okay. So this job is already fixed over here, right? With the help of this chuck key. This is called chuck key, which can be inserted in this hole and will be rotated clockwise and anti-clockwise. So anti-clockwise is to tight, and clockwise is to clockwise is to tight, and anti-clockwise rotation is to loose the job. Okay. So it will be shown. ताइडी जी एक बार करिए उसको. हाँ, it is loose now. Now it is tightened, right? So those 3 jaws at 120 degrees from each other. ये भी 120 डिग्री है, ये भी 120 डिग्री है, 120 डिग्री में ये टोटल. ठीक है. So job is fixed. Now we will center this job first with the help of this tool. This is called universal surface gauge or level gauge, right? Which has got a base, which has got a column over here, the clamp, then the pin. This job should be parallel. The axis of this job should be parallel with this horizontal line, right? And you can see there is there is a difference between this, right? So this difference will be aligned. So slight adjustment has to be done. Okay. So now the job is aligned. So what will we do? What we will do? We will tight it firmly after alignment, right? And then we'll remove this surface gauge. We'll keep this in the tray pan, the chip pan, and now we will adjust. We will machine it with the help of this single point cutting tool. This is called single point cutting tool, right? This tip of the tool, does all the work. You see, this is tool, right? And now it will be fixed in this tool holder, and this tool holder, okay, this tool holder is fixed in the tool post. This is called tool post, and this tool post is saddle को इधर लीजिए थोड़ा. See how the saddle is moving. Okay, this tool post is mounted on the compound rest. This compound rest give you x and y axis feed, right? This is compound rest, and this compound rest is mounted on the cross slide. This is called cross slide. This is the cross slide. मैंने बोला था ना आपको कि travel is perpendicular to the axis of the rotation, right? That means it reduces the length, right? And this is called carriage completely. This is the carriage. This carriage moves forward and backwards. Okay. So this cross slide in one complete rotation of this wheel will move 5 mm back or forth. This will give the motion to this part, which is cross slide, which is mounted on those guideways, right? The complete rotation of this wheel will move this cross slide by 5 mm, right? And complete rotation of this particular saddle will move the job by 30 mm, right? And you see it is moving. So a complete rotation gives 30 mm of forward or backward movement, and 1 rotation for cross slide gives 5 mm back and forth. Okay, now we will perform first operation on this job, and that operation is called as facing. So we will remove the material from this part, right, this face, that so that it will be the length of this particular shaft will be reduced. Now there are two things, one is called feed and one is called depth of cut. So for facing operation, the depth of cut is given by the saddle, this carriage, right, this wheel, the depth of cut, that means how much material has to be removed, and depth of cut remains constant for that particular cycle. But the feed is given by this cross slide. So it will move from center to out or out to center. Okay. So in facing operation, feed is given by, feed बोलने का मतलब है per revolution वो कितना material remove कर रहा है. So that is called your feed. And depth of cut, which will be depth in the job, how much material has to be removed. So that is your depth of cut. Okay. So depth of cut for facing operation is given by the saddle, and the feed is given by the cross slide, because we have to remove the material from this face, inward to outward. Okay. So that is facing. When turning comes, the depth of cut is given by cross slide and the feed is given by this saddle. So we will see that. See how the material is getting removed, right? So this tool is firmly mounted on the tool post, right? So this is called facing operation. Now you see the cross slide is moving outward and removing the material from the stock. Okay, you can see the movement. The depth of cut is given by this and the feed is given by this. So little bit of adjustments. So this is called tool holder. This is the part which is called tool holder. Okay, because the tool is not in the center, because tip of this tool should be coinciding with the center of the job, right? So it was not coinciding with the center. That is why little bit of adjustment has to be done, right? So disengaging the tool holder and giving some sort of seams beneath the holder so that the tip coincides with this. So there is one method also. You can coincide your tip with this tail stock. ये टेल स्टॉक है पूरा आपका. इस टेल स्टॉक का जो ये टिप होता है, यहाँ पे आप टूल को सेट कर सकते हो. और ये जो टिप अगर आपने यहाँ सेट किया तो अल्टीमेटली इट विल बी कोइंसाइडिंग विद द जॉब, बिकॉज एक्सिस ऑफ हेड स्टॉक is perfectly in line with the axis of tail stock. The construction of machine is like that, right? So see how it is done. So this is the center. This is the center of the tail stock and this is the tip of the tool. Now you can see there is a bit of coincidence over here, completely coinciding with the center. Now our setting is done. So we will go to job again. So operation continues. The machine is start, and now removing the material. The material is getting removed. This is called facing operation, in where we will be reducing the length up to acquired or already decided length, and that is 95 mm. Okay, so हमको क्या करना है, टोटल डेप्थ जो है वो टोटल डेप्थ 5 mm से कम करना है, लेंथ जो है 5 mm से कम करना है अपने को, right? So you can see there are few particles which are coming out of it, and those are called, these are the chips. These are called chips. As the mild steel is a ductile material, the chips will be continuous. Those are continuous chips. Can you see the chip? This is continuous chip. The material what is getting removed from this job. Okay. So facing operation is towards the completion. We will be giving the finish cut. This is the finish cut, final cut, and we will start our machining, turning. Okay. So this is the first process, which is facing operation. So you people should be very clear to and understand this particular thing. Why? Because you have to make your process sheet according to those processes. Okay. So facing is done. See the smoothness, right? Job material is removed. You can see circular lines also on that. All because job is rotating and tool is traveling outward or inward, right?
Marking.
Now we'll go for marking. So with the help of some paint or chalk or anything, you just will make those patch here. And now with the help of inside, this is the inside caliper, already I have told you, this is the inside caliper. You will mark the dimension of 55 mm first, because what we have to do, we have to do 20 mm, 35 mm and 40 mm step turning total करना है. तो हम लोग क्या करेंगे, फर्स्ट 20 एंड लैटर 35. तो 16 mm फॉर 20 mm एंड 19 mm फॉर दोस 35 mm. सो वी विल मार्क ऑल टुगेदर 35 50 20 plus 35 is 55. So this is the marking. You see, this is the marking of this is the temporary marking. Okay, this is the temporary mark. Now what will be done? We will make a mark of permanent mark with the help of tool on this particular line. See, the tool is getting coincide, and now there will be permanent marking. See, this is the permanent marking of 55 mm. That means we have to go 20 mm, 16 mm, and for 35 remaining 35 mm we will make 19 mm of diameter, 16 and 19. So we will first make it 19, and then we will reduce it to, again we will do the marking and we'll make it to 16. Okay. So already we have done first facing, we marked it, and now we are going for turning. So we will keep the depth of cut, right, according to the final dimension what we will be needing here, right. So what we need 19 mm diameter for 50. First step, the first step is to make this rod up to this marking measuring 19 mm. Okay, so already we have measured it 25 mm. That means how much material we will have to remove? We will have to remove total 6 mm of material, right. Now if you give depth of cut, if you give depth of cut, that means you are inserting this tool into this job, right, so that the diameter of this rod will be minimized or reduced to 19 mm. That means if I give the depth of cut of 1 mm, that means
1.5
1 mm or 1.5 mm, we will put it 1.5. Now on the dial we have set 1.5 mm. Okay, if 1.5 mm is set, that means this tool is now into the job radially. That means the total material what will be removed will be 3 mm. So we will reduce the diameter of this job to 22 mm, because we are reducing it from one side, na? So it will be automatically reduced from other side. Radially we are inserting the tool by, we are giving the depth of cut by 1.5 here. Can you see? The tool is inside the job and that is 1.5. So it will reduce the diameter, it will reduce the radius by 1.5, that means diameter by 3 mm. So the final, after this cut up to this marking, we will be getting the diameter of 22 mm first. Okay, so step by step we will have to move. Okay, so start. So see the machining. So this operation is called as turning operation. This is the turning operation, right? Reducing the diameter by giving the depth of cut of certain amount and moving the job along the axis, moving the tool along the axis so that the diameter can be reduced. This operation is called as turning operation. So there are several chips moving out of cutting. You can see the generation of chip here, right? So this is the machining zone, actual machining zone, where tool is in direct contact with the job, right? So we are reaching the marking, what we have marked, 55. Very fascinating, isn't it? The job is getting cut. Oh, at last we reached the marking. Done. So this is now the diameter is 22. But how come it is 22? We will check it by either vernier caliper or by this outside caliper. That means we will match those two jaws to the outside part of this job, outside surface of the job, and now this is compared with this, right? And then we will check on the ruler scale. See how we how much we have achieved. It is 23.5. That means the depth of cut was 0.75, right? The depth of cut was 0.75. Now again we will give that depth of cut of 0.75 and we'll reduce this job. Okay. Now again we will move this cross slide. We will give the depth of cut of 1.5 mm. That means diameterly 1.5 mm. Okay, that means this tool will get inside by 0.75. Okay, so now see, the generation of chip. is how the machining is done. You see? See, continuous chips are getting generated. These are the continuous chips. Seen this in slow motion also, I guess. I made this slow motion also. So chip always get curled. Okay, all because of the angles that are provided on the tools. So the diameter is reduced to 22 now. Okay. Or whatever the dimension, we will check it by outside caliper, because we need to be very confirm. Okay. So see. Okay. This outside caliper jaws are at the surface. उसको बाहर लगाना है, उसके surface पे just उसके jaws touch होने चाहिए. Okay, and then see what we have achieved. We have achieved 22. Now again we will do the same thing so that it will be reduced to further dimension. Again by 1.5 we will reduce it. Diameter we will reduce it by 1.5. So these are the steps. So this is set. And now the feed is given by this wheel. This is the carriage wheel. So carriage wheel is ascending this whole thing, whole carriage into the job, and tool is mounted on it, right? The carriage, the cross slide, the compound rest, and this is tool post. This is tool holder, and this is actual tool. So see how many members are there, right? But the actual cutting is done by tool. So the control of feed, control of depth of cut, control of the feed gives you the right dimension. नहीं तो क्या होगा? There will be, अगर ये सब controls यहाँ नहीं है, तो there will be n number of vibrations, and those vibrations will ultimately spoil your job, right? So this is how the things go. So you can see chuck is moving, rotating here. So this is your chuck, the job. So there are n number of linkages. See the complete movement. So this is the complete setup, right? we are reducing the diameter with the help of turning. Turning is to reduce the diameter, right, along the length. Done. Okay, now we will measure again how much dimension we have achieved for this shaft. Okay, so the same procedure, outside caliper, the surfaces will be touched. Okay, just touching the surface, outside surface of the job. Okay, then comparing it with the steel rule.
20.
So we have achieved 20.5 maybe, right, because we have reduced it by 1.5 mm. So this is, now we will take the final cut because we will reduce this diameter to 19. Okay, so we will take the final cut. So this is the final cut of the same 1.5 mm. The feed will be given by the saddle. The job goes into, right? So this is how it looks from the machinist's angle. Machinist stays always at the wheel side. This is the wheel side. Okay. The saddle is giving the feed. This is constant. Cross slide is constant. Why? Because the depth of cut is given by cross slide and the feed will be given by this way. And now this at what speed it is rotating, that is called cutting speed. Okay. So this is revolution per minute, RPM. So this is will be converted into linear velocity, pi dn जो आप करते हो, pi dn by 60 meter per second or meter per minute, whatever. So this will be your cutting speed. So there are three parameters in machining. Cutting, one is speed, one is depth of cut, second is feed, and third is cutting speed. All three parameters are very much important. Okay, and they are interlinked also. For with maximum depth, if the depth of cut is large, feed should be small and your cutting speed also should be small. नहीं तो क्या होगा, इसके ऊपर में टूल के ऊपर एग्जैगरेटिव लोड आएंगे और टूल टूट जाएगा. ओके, बिकॉज टूल ऑल्सो हैव सम फेल्यूर पॉइंट्स ना. डेप्थ ऑफ कट ज़्यादा है तो इसका मतलब है सरफेस एरिया, वॉट एवर द सरफेस एरिया विच विल बी कम इन कॉन्टैक्ट विद द टूल टिप विल बी लार्जर. And if that is the case, that means your tool will be facing hell lot of pressures and the tool will break down. So to avoid that, we have to keep optimum feed, optimum depth of cut and optimum speed. For larger speeds, you have to keep feed smaller and depth of cut smaller. For larger depth of cuts, you have to keep feeds and depth of cut smaller. Speed small, speed at minimum. So now we will again compare this with the help of outside caliper, right? Just touching the surfaces on the tip of the jaws, and it is compared. Now we have achieved 19 mm. Can you see? We have achieved 19 mm of diameter. So our final diameter for that step 2 is achieved. Now we will mark again on 20 mm. So from here 35 will be marked. ओके, सो 30 इधर से 35 मार्क कर दूंगा तो क्या हो जाएगा, सॉरी इस एंड से मुझे 35 मार्क करने या फिर इस एंड से मुझे 20 मार्क कर, बिकॉज टोटल लेंथ व्हाट वी हैव अचीव्ड इज 55. कैन यू सी, वी हैव अचीव्ड 55 mm all the way. Now on 20 mm from this side, 20 mm we will mark so that we can reduce the diameter by 3 mm again. That means the final dimension what we will be achieving is so patch up the paint or chalk and taking the dimension in inside caliper, right, and now marking it on the job. जॉब गर्म है, कटिंग से ना चीज़ें गर्म हो जाती है, जॉब गेट्स हीट बिकॉज स्ट्रेसेस बहुत ज़्यादा हेवी है ना, कटिंग स्ट्रेसेस। सो ब्राइटनेस बहुत ज़्यादा रहने की वजह से आपको मार्किंग दिख नहीं पा रही होगी, बट यहाँ पे वो मार्किंग है। नाउ वी विल कन्वर्ट दैट मार्किंग इनटू परमानेंट मार्किंग। ओके, सो जैसे हमने पहले किया था वैसे ही सेम। ओके, सो इट इज़ मार्क्ड, so permanent marking is done. This is on 20 mm, this is 20 mm from this end, this is 20 mm. Okay, now we will turn it, that means remove the material from the diameter, reduce the diameter by 3 mm. Again the same procedure, we will give the depth of cut with the help of this cross slide wheel for 1.5 mm, and we will give the feed by this saddle wheel. It is going all the way inside the job, the same procedure. You can see the beauty of removing the material. Fascinating ना, बहुत मस्त लगता है. So chips are getting removed by the action of tool on the job. Tool is harder, job is softer. Both are made of steel. The job is made of mild steel. The tool is made of high speed steel. So the marking is achieved, done. We will verify the diameter with the help of outside caliper. So I guess it is 17.5 because 1.5 mm we have removed. See how many chips are there. So this is the removed material. That is why this process is, machining process is a subtractive process. So see what we have achieved, 17.5. This is 10, 15, 16, 17 and 17.5. So now again we will remove the material by 1.5 mm from here. So giving the same thing, depth of cut and then feed. This is the final cut, okay? This is the final cut. Okay, done. So we have achieved two things here. That means 50% of our job is completed, more than 50%. There is 16 mm here, 19 mm here, the length is 20, the length is 35. So we have done it. Now we will go for chamfering here. So setting the tool at 45 mm, 45 degrees by adjusting this approximately 45 and adjusting by this lever. This is tool post lever. Okay, now this is the chamfering and this is approximation basically. Done. So can you see the job now? The edges are blunt. जो पहले edge था अभी वो edge blunt हो चुकी है. See, edges are blunt. And this is 16, this is 19. So job from one side is completed. So why it is needed in one setting? That means if you set the job once, you have to complete maximum operations what are on the open side. This is the closed side, this is the fixed side. Now we will turn this job and we will make all the dimensions on this part, that is 22 mm of diameter and 40 mm of length. Okay, so unclamping the job for further setting with the help of chuck key. The job is removed from the chuck and it is turned 180 degree and then it is fixed by turning this chuck key. Okay, the same procedure we will follow with the help of this universal surface gauge, or what is say level gauge. We will again align the job horizontally. Okay, can you see? So job is aligned. perfectly. Now the tightening the job fully. And then removing this surface gauge, putting it in the tip tray, and now we will mark it, the same procedure, but the marking should be done from this end, machining end, not from this end, because we will have to reduce this by facing operation. The length will be reduced and up to the length. And what is the length now?
44.
So we are having the total length of 44 mm. That means 4 mm material has to be removed from this surface. Okay, so we will mark it here. 44. So the same procedure, with the help of outside caliper, we will take the dimension to 44. See, 44 आ गया, 40 आ गया, right? इसको 40 पे हमने adjust किया इसको, and from this side it is 44. Now we will mark it on this. Yes, this is 44.
40.
This is total 44, and now the marking is at 40. This is the temporary marking. Now we will make it permanent. Okay, this is the temporary marking. Now with the help of tool, we will make it permanent. So coinciding the tool at the marking and moving it. So this is the permanent marking. So this much of the material, that means this much of the length has to be reduced from this top. Okay, so we will reduce it now by setting the tool at some angle, maybe 60 degree, and then going for facing operation. So this is the facing operation. You will see the length will be reduced, right? Length is getting reduced. So now in facing operation, what is there? The cross slide is in operation. The feed is given by cross slide. See, the cross slide is taking this whole thing backwards. And the depth of cut is given by this wheel. Whereas in turning, the reverse thing happens. The reverse thing, we do the reverse thing occurs. See, is taking the tool inside and now giving the feed. See, so marking is, we have just achieved the marking, right?
Final cut.
So now we are very near to marking. That means we will take a final cut. This is the final cut. That means the dimension is achieved. Right? So dimension is achieved.
Length achieved.
So dimension बोलने का मतलब the length. What we have marked on lengthwise 40 mm. Now we will verify whether it is 40 or not. See, it's 40. Can you see this? Exact 40. Huh? So this is 40 mm now. Now we will turn it up to 22 mm. Right?
Give a cut.
एक cut. So we will turn it to 22 mm. Okay? So the same thing, giving the depth of cut, right? And now the feed. See, the removal starts. See, you can justify the difference. This is the raw stock. This is the raw stock, and now we are machining it. Can you see the difference? So we have taken bigger depth of cut. So the color of the chip also get changed when depth of cuts are higher, and the chips are very much dangerous. They burn. See, I got the burn. This is the chip burn. ये देखो मेरे हाथ में भी चिप चिपक गई थी और आप देखो यहाँ पे मुझे जल गया. So the energy is too high. और देखो ब्लूअर, those ब्लूअर chips are high temperature chips. Those are burned chips and they can burn your skin also like mine. ये कभी कभी होता है, but you have to be very careful. You have to be very careful while machining, right? सी पहले के चिप्स आपने देखे होंगे, वो आपके थोड़े से ब्राइटिश दिख रहे थे. नाउ द चिप्स आर येलोइश, ब्लूइश चिप्स आर देयर, राइट? ऑल बिकॉज ऑफ द बर्निंग. सो इतना टेम्परेचर विस्टैंड करता है ये पर्टिकुलर टूल, राइट? द मशीनिंग टेम्परेचर गोज, एंड कभी कभी आपको रेड भी होता हुआ दिखेगा वहाँ पे, अगर ज़्यादा कुछ हम लोग करते हैं तो. यहाँ पे नहीं दिखेगा. ओके, सो टेम्परेचर गोज वेरी हाई. दैट इज़ वाई दे यूज़ कूलेंट्स एंड ऑल. कभी कभी अब का हमारा जॉब छोटा है इसलिए हम लोग उसको कूलेंट यूज़ नहीं किया, बट दे यूज़ इट. नाउ वी विल वेरीफाई इट विद द हेल्प ऑफ आउटसाइड कैलिपर, राइट? See what we have achieved. We have achieved 22 mm exactly. So this is 22 mm. Now our job is completed. Just one thing is remaining, then that is shampering. So approximately 45 degrees पे हमने उसको सेट किया टूल को, and now we will engage the tool here, and can you see shampering is done. Okay, so this is how the job is made. Now we will unclamp the job. So job is bit hot now. So we will take it to the job drawing now. So this is our job drawing, right? This is our job drawing, right? And that's our job, what we have made right now. You see? See, this is our job and this is our drawing. So we did this. Our practical is complete, isn't it?
Raw material.
And see, this is your, you can see vis-a-vis comparison. From this raw stock, we have manufactured this by removing the material in controlled manner, right? And this is the final job according to this drawing, right? Raw material is this and finished job is this. Okay, so this is how the machining is done. Okay, I hope you people have enjoyed this practical, right? So I hope you people have enjoyed this practical. This is our practical for manufacturing the job on lathe machine. Okay, so we have done all the operations. I'll give the brief. We have taken the raw stock from the power saw. The raw stock is there, right? We fix that raw stock here in the chuck with the help of cross slide and saddle. We control the movements of the tool to the dimensions. We compare the things with outside caliper we used this inside caliper for marking, right? And for the comparison sake, we have used the steel rule. If we would have used vernier caliper, all those three things would have been not used over here. But to make you aware that such type of gauges are also available for comparing and measuring, we have used those tools, right? So this is the practical for machining. Physical performance is over, and thank you very much for your listening. Thank you.